chunk form, I get x to the negative 8, y to the negative 16, z to the negative 8. That's all of that would be down the bottom, but I'm going to send all of it up. So my numerators become x to the third, y cubed, z squared, x to the 8th, y to the 16th, and z to the 8th. Just by moving all of that up. Okay. I like to put things in descending order. I'm thinking x, y, z. I'm just putting those in order. It doesn't matter. 3 times 3 is 3 times 2. So now I start combining them. I have 11 x's, x to the 11th. I have, 19 y's and 10 z's. Locally dokely. Why don't you guys give me that worksheet? We'll call it even. That's too much stuff. You did all three, doesn't hurt it. It doesn't change it. Potatoes, Yes, ma'am. Yep. That's all that matters. When end behavior you're just looking at is it a positive or negative? Okay. That's it. So we know what we should do real quick. Since they told us next door is taking a test right now, she told me not to annoy them. We should all walk to the back wall real quick and go up to the wall and say, "Good luck on your test." Yeah, that's a good idea. Let's do it. Oh. Stranger danger! Stranger danger! That was supposed to be funny because it's like stranger danger. You're not a stranger, nor are you danger, All right. So, I don't know. I've decided what we'll do on that. So this week, like I was saying, what we've got today is adding, subtracting, and multiplying polynomials. Basically, this works out to be combined like terms. Distribute combined like terms. This is ridiculously simple. Not really. Now, one of the things that I would suggest, or that I've always, whenever I do this stuff, is that textbooks, worksheets, Kudo software, they always write out addition and subtraction problems horizontally. I would always say to rewrite them vertically. And I'll show you the reason why I would do that. So basically, like I was saying, polynomials, if it's a third degree polynomial, how many terms should it have? It should have 4 terms. If it doesn't have, if it's missing a term, what do you put in there? Put a 0 like a placeholder we have been doing. And basically what we're going to wind up doing here is I would suggest that you, when you write this out, if you know it's this plus that, write down the first part, space it out a little bit. See how I just spaced it out a little bit with the signs? And then I'm going to line up the second part below it. X cubed. Oops, sorry, this was an X cubed here. And what I'm doing 4 addition problems. Just by doing that, I'm just breaking it apart, so that way I don't accidentally do something stupid. I'm adding between all of these. The screen is so messed up. These cords. And what's 3x cubed plus x cubed? 4x cubed. 2x squared minus 10x squared, negative 8x squared, negative x plus 0x, negative 7 and 8. And there's your answer. Like I said, this should not take you very long to understand. All you're doing is combining like terms. That visual way of doing it, like I said, it spaces it out, and it helps you to make sure you put things in the right position. That's really all. The only reason why I do it that way. Okay. Do you have to do it that way? No. Will you be less likely to screw up if you do it that way? Yes. What changes if there's subtraction? You subtract everything. That's it's not so much super important for addition, but for subtraction, doing it this way, it reminds you that you have to subtract each piece, as opposed to distributing. Parent-teacher conference prep time. They always give us the half day the week before conferences to get a bunch of stuff ready. It's not usually as much at the high school for us. It's pretty easy to get stuff set up, but for middle school when they're doing all of the kids or like the team stuff they do, and then they have like elementary schools, 30 some odd kids, you have this big detailed reports on. I mean, I have 36 slots and 36 schools, so I have a lot to do. I don't know high school teachers do. And this one here, same idea. Subtraction. These chords are driving me nuts. Again, as I go through this, guys, I always write it, space it out just a little bit. And make sure you're putting the subtraction symbols between all three. Because now you know that I know how you guys do distributed property. You forget to send it to the second term. When you have polynomials and you're subtracting, you'll forget to send it to the second, to the third term, or the second, third, fourth, and the fifth term. That's why I always rewrite these things vertically, to space it, and to make sure that you put a subtraction symbol between each piece. Right? It's just a mental way of doing it. There's no rhyme or reason. It's just keeping things straight. So, all right, ready? This is tough. I know you can do this. This is Tuesday, and I was gone yesterday, so I'm excited for you guys to be able to math here. 5 minus 3. You don't really need to. It's okay. All right. 1 minus negative 6. Negative 7 minus negative 1. And go on your merry way. I know. It's spectacular. It is. I haven't dressed up in years. My children, I have Connor is the Harry Potter on the. What's the thing they fly around and play? Yeah, he's that guy. And then Moose is an army specialist SWAT team kind of guy. Moose wants to be a cop, so. I don't need any more of those. Oh no! Oh no! No, it's not foiling. It's not, because take a look here. You can't foil that. There's no, because you have a. You want to grab that marker? Hey, why don't you just have class outside? Oh. He's like. Anyway, multiplying, basically this is distributing out multiple times. So as you do this one, I know you guys all know how to do this. Just please draw your arrows. You don't forget to send it to 1. And just multiply through. 3x cubed, 2x minus 2x squared minus a 4x. And then draw the arrows going the other way with the other term. I know, this is the one day it's usually pretty quick. So you get negative 9x squared, positive 6x, and positive 12. And what do you think you have to do when you're done? No, descending order, combine the terms. Okay, yeah, that's all it is. Just distribute over. As you go through, make sure you go into a descending order. Descending means you start with the highest degree, work your way down. If this is a 3rd degree polynomial, how many terms should you have when you are done? Or if you don't have one of the terms, do you have to put a 0? You don't have to. So you could have, I should rephrase it, you could have up to 4 terms in the sequence. That's the maximum amount you can have. You can have less than that. You can't have more than 4. So we have 3x cubed. And again, a lot of times when I do this, I cross off what I've done. The other thing that I do when I have them in a string going horizontally, when I go to see what's next, I underline. So I have negative 2x squared and negative 9x squared. When I put those together, I get negative 11, good. Negative 11x squared, and then I cross them off. Underline. And then here's my polynomial. These little nuances of stuff that I do, you don't have to do them. All I'm saying is it's just a way to visualize it. It's a way to make sure you don't make a dumb mistake. That's really all it is. Okay? That's really all that is. Oh no, I am so afraid. Well, there's a couple ways you can do it. Let me ask you this. What's 2 times 3 times 4? 2 times 3 times 4. What's 3 times 2 times 4? 4 times 2 times 3. 3 times 2 times 4.
Yes, they are. Just kidding. Oh my God.
So, anyway, it's just you're messing with us because it's Halloween. She's trying to be spooky. In math, the order in which you add, the order in which you multiply doesn't matter. So it also does the same thing when you're multiplying out polynomials. You don't have to do them in order. You can put them together however you want. Personally, what I would do is I would always leave the first term, and I FOIL out the second, and I get x squared minus 7x plus 10, and then I would distribute that. Because then it looks like the problem we just did a second ago, where you always distribute the front first, and then you send that value through. Okay. Do you have to do it that way? No. All I'm doing is just making it easier to myself, because to me, I know that I like to distribute going from the left to the right, as opposed to right to left. Makes more sense. So if you do that, then you're going to get x cubed minus 7x squared, 10x. And then just combine it through, because the order in which you multiply doesn't matter, as long as you do it correctly. Because 2 times 3 times 4 should always be 24 in any order. And there you go. What are the tails doing on this one? Down, up, okay. They go down, up. Where are your zeros located? After what? I'm sorry. Oh yes, yes, there should have been. Sorry, but I combined them through correctly. What were the zeros? I'm sorry. 4, 2, and 5. Okay, so my zeros were at 4, 2, and 5. So that means that my tails are doing something like this, and the graph is doing something like that. Yes. All right, let me ask you this. If 2 is a 0, what's its term? If 2 is a 0, what's its term that generates a 0? X minus 2, okay. So remember when we talked about this? Remember when we talked about the idea, excuse me, we had, what was it, x minus 4, x minus 2, x minus 5. If you multiplied it all, you get that. Are we okay with that? So the idea was, what was the example we did in class? Oh, we did this. What's 18 divided by 3? 6. Multiplied through, you had no remainder, correct? That meant that 3 was a factor of 18. It went in cleanly. Whereas if I did 18 divided by 5, I get 3, 15, I got 3.6. That meant it still was divisible by 5, but it wasn't a true factor because of the remainder or because of the decimal. Now, what happens here within polynomials if I divide by the 0, I don't have a remainder, which makes this a term, which makes it a factor, which then leaves you what times what's 20? You gotta get negative 9. Which were your other terms? No, you'll learn how to find them. You'll learn how to search for zeros. Yeah, there is a little bit of it is. There's a little bit of a guessing game that goes along with playing when you're searching for zeros. And it's actually I shouldn't say fairly, it is really, really easy. Because you guys all in agreement with me on this, that if I say synthetic substitution, synthetic division, it's pretty stinking simple. It's very procedural. You just do the same thing over and over again. And you get good at it, you get pretty quick at replicating it. That's how you search for zeros. We'll get to how you find them. I don't know if we'll get to it this week, but we'll definitely get to it soon. But yeah, this is kind of where this is all leading. Good question. Led right into. Now, these are some of the old pattern stuff. If you recognize them, great. If you don't, eh. Oh. Write it twice. Write it twice, ladies and gentlemen. Please don't kill the puppy. No.
He showed up.
Yeah. Yeah, it's sad. So here's the deal, guys. When you have junk squared, please remember that means junk times junk. It does not mean 81y squared plus x to the fourth. It does not mean that. All right? You need to FOIL it out. Like Nora said, write it down twice. Okay? Your best bet for something like this, whenever you see junk squared, just write it twice. Okay? You're going to be less likely to make any mistakes. And then you just want to. Yes. Nope. When you have junk squared, that means there is a special pattern that occurs. But there's no reason to memorize special patterns when you'd have to sit there and math it anyway. Whenever you have something squared, just write it down twice and FOIL it out. It's the easiest way to remember it. FOIL it out, you're going to get 81 y squared. Then it'll be 9y x squared. 9y x squared, both negatives, becomes 18 x squared y. And then it'll be plus y or x to the 4. No, that's fine. Yeah, because what's 2 times 3? What was it? And 3 times 2 is? Did the order matter? No. Unless we both find a 24, then you get all sorts of stuff. Okay. Hey, yes? No. No, this is fine. This is fine. You don't have to. You just leave it how it is. I just want to make sure you guys saw that. Same thing happens if you have anything to the third. Instead of trying to remember all the different patterns that are out there, just remember that means this is just AB plus 2, AB plus 2, AB plus 2. All right, just remember that's what that looks like. And I'd always take care of the last 2 of them first by FOILing out, and then distribute that first one. That would be the easiest way to do that, instead of trying to remember all the different patterns that are out, trying to do all the extra math. What? Oh, I'll walk through it. It's not a big deal. So we do this, if I FOIL out the other side, we're going to get a squared, b squared, plus 4ab plus 4. Just what? First, outside, inside, last. And I just combine the 2 middle terms. I'm sorry, I didn't hear all that. Yeah. Unless you wrote it as AB quantity squared, and that would be correct, because then it's still the same thing as A squared, B squared. Does that make sense?
Yeah.
Good question. So then you distribute out again, you're going to get A cubed, B cubed, plus 4A squared, B squared, plus 4AB, 2A squared, B squared, 8AB, and 8. What? It's just a lot of letters. It's probably one of the easiest things we've done all year, in all honesty, when you start just distributing properties and stuff like that. It's just a lot of letters. So you can get lost in lettering if your handwriting is subpar. So hopefully your handwriting is pseudo better. And the only other thing I wanted to just kind of quickly show you guys is where does this go? As we start to FOIL things out, multiply things together, you're getting your terms. Well, tomorrow we're going to take all those terms and factor. And this is where we're heading into tomorrow. Now, I know that most of you guys despise factoring, which is it's okay. It's all right. But the idea is there are certain tricks, especially with polynomials, that if you look for certain patterns, it becomes easier. For example, in this case, how many terms are there? 4. Okay. Once you see 4 terms, that should be a dead ringer that you're going to want to group. You group and look for GCFs. Okay. When I do that, that's remember how we did when we had leading term coefficients that weren't equal to 1 when we had trinal. Yeah, trinal. Yes, sir. I changed it from a minus. When I remember having the third term that was negative, remember how we did that with just the regular old trinomial? Quadratics. Sorry, that's with the quadratics. Whenever you had to split that middle term out, that's what we did. Yeah. No, because what was negative here? It's just the 9. So if I do a plus minus, it doesn't change it. See what I'm saying? The reason I do that is so when I factor GCFs, I remember taking the negative out. X cubed and 2x squared, what do they have in common? X squared. Take out an x squared, what are you left with? 9x and an 18, what do they have in common? 9, but I'm going to take out the negative because that's why I reminded myself of that. If I take out the negative 9, what am I left with? X minus 2. Hey, aren't these two the same thing? That's a good sign. When that happens, you write it down. And what's left? X squared minus 9. Hey, is that a perfect square? Is 9 a perfect square? Is that a subtraction symbol? Which means it can get factored further. Yeah, it can. What does it become? X minus 3 and plus 3. Remember, difference of squares means you have 1 plus 1 minus. And that's kind of what we're getting into tomorrow. And I think that using, let's see, Wednesday, Thursday to go through 6-4, that'll be plenty overtime. So we'll play it by ear if we're going to do a short quiz or not on that half day. I'd like to because after 6-4, 6-5, 6-6, 6-7 all use different styles of things. It's almost like a tale of 2 different types of total polynomial work. And I think it might be a pretty good idea to do that. So, but I'll know for dead certain probably by about halfway through tomorrow where we're sitting. But I'm pretty sure we'll be okay to do a short quiz. If we have what 25-minute periods, that's plenty to do a short quiz. I mean, it's not like it's the comic stuff where we have to do 7,000 different things to it. I mean, here I could throw a couple add, subtract, multiply, simplify, and then a couple quick factor things. Easy. So we'll see how it goes. Okay. Let's see. Homework-wise, I had. She actually has strep, unfortunately. So, yeah. It's tough because she's still full-time student, so she still has a full class load. So she's only able to make it a certain amount of days, or certain days and certain times throughout the school year for the first semester. But don't worry, second semester she'll live here. That's good. Yeah, that'd be fine. There's a couple add, subtract, couple multiply together, a couple of the junk square, junk cube, and special product stuff. So that's just good. Always put them into a descending order. Excuse me. go from there. Let me double check. For some reason, I have a feeling that I didn't